In this video, we'll take a look at graphing the special quadratic equations of the form y equal ax squared with no linear or constant term. And to illustrate what this form of quadratic equation results in, let's graph the following equation, y equal x squared. To do so, we'll complete a table of values. Starting with x equal -2, plugging it in place of x, we find the corresponding y value of 4, and plotting the point. Continuing on, we'll find several other ordered pairs, plotting each as we find them. Once we have several values, we'll use a smooth curve to connect these points for the graph of this quadratic equation, which is a parabola. The axis of symmetry of this special type of quadratic equation is the y-axis. The point of the graph or equation that is on the axis of symmetry is the vertex, and you'll see here that it is the origin. This is acting as the minimum point for this upward opening parabola. Let's take a look at another example of this special quadratic formed equation with no linear or constant term. In this example, we are asked to graph y equals -1/2 x squared. To do so, we'll find some values. Here, x is equal to a -4. Replacing x with -4 and simplifying, we find a corresponding y value of -8, and we'll plot that point. We'll continue finding several other points and plotting them, connecting these points with a smooth curve. Here we have a parabola that opens downward. If we note, this equation graphs very similar to the last example as all equations of the form y equal ax squared, with the axis of symmetry being the y-axis. Further, the point that intersects the axis of symmetry, which is known as the vertex, is at the origin. All equations of the form y equal ax squared will have an axis of symmetry as the y-axis, and the vertex, the point on the axis of symmetry, will be at 0, 0, or the origin. It is the leading coefficient that determines whether the parabola opens upward or downward. Here we have a leading coefficient that's negative, and if you see, we have in fact a parabola that opens downward. In the previous example, the leading coefficient was positive, and as a result, the parabola opened upward. If the leading coefficient has a value that is between 0 and 1, whether it's positive or negative, these rational values between 0 and 1 will flatten out the parabola. As the coefficient increases greater than 1, the parabola will become narrower the larger that leading coefficient is.